Hello and welcome back everyone to Space Simulation Toolkit, and let's talk today about a little something that I've been keeping in my back pocket for the moment the last update came out. So you'll remember in the last update, when objects hit each other, they now release heat, which is fantastic because there's a great way to make things hit each other. Magnets exist in this game, but the fun thing isn't just what you can do with magnets. So let me go ahead, there's a magnet right here. And let's go ahead and set its multiplier just to about 1 so you can see what a magnet normally does in Space Simulation Toolkit. Alright, I put down some metal. Also, you can pause by pressing space now. Super useful feature. Thank you, Mr. SST, for listening to our prayers. As you can see, the magnet is accelerating the metal towards the magnet. But here's the interesting thing. Because this is Space Simulation Toolkit, I can go ahead and I can make that negative, which means that I can repel the metal away from the magnet. Now, repelling objects is much cooler than attracting them. That is going to come across as such an incel thing to say there, but there's a reason for it. And that's that we can accelerate things in a specific direction because they'll get accelerated away from the point. So if I put something here, it's going to get accelerated to the right. And look, it kind of looks like a bullet. And guess what? That's what this video is about. Bullets in Space Simulation Toolkit. So for example, if I build a big rock wall here, probably should have paused to build this, but it's okay. And then I go ahead and build a bullet. Ah, this is going to be amazing. Oh my god, do you see that? Okay, but it gets even better because that's without heating enabled. So once we go ahead and enable heating, we're going to basically get the equivalent of tank shells. And before we go any further in this video, I need to do my due diligence because too often people see things on YouTube, think it's cool, and then make a similar video and then don't give any credit for the original video that inspired them. So I want to give 100% credit here to this guy right here, Tumble Trash, who went ahead and made an armor video, and it was fantastic. And with this latest update, I think I can take it a step further. But thank you for starting this because this is a fantastic idea. And we're gonna go ahead and finish what he started by turning on CDE heat. Building a really big, it becomes a little hard to build when CDE heat is on if it's not paused, so make sure you pause first. All right, so we're gonna build. May also have to turn the particle distance up a little. Yeah, we're gonna turn the particle distance up a little bit so that it doesn't kill itself. C distance, we're gonna turn up to like 1.1. Yeah, 1.1 is enough to make the it's because occasionally it places a particle inside of another particle, which causes a collision, which causes heat, which can be a problem. But as you can see, setting the C distance to about 1.1 gets rid of that problem pretty much completely. And now we can go ahead and test. I'm actually going to make this a lot larger. I want to see just how far this shell is going to penetrate. Remember, we don't even have like the settings absolutely insane right now. The maximum velocity of the simulation is set to 300 and the magnet can be set to like 1 billion force. This game has no limits, and that's one of the great things about it. So we can have a ton of fun with absolutely ridiculous simulations. But now we have this massive block of hundreds of thousands of particles. And I'm going to go ahead and turn the maximum velocity of the simulation way up. And we're going to pause, build a projectile. I'm going to try to make this kind of look like a bullet. I'm not an artist, but we're going to kind of sharpen it a little bit. That's way too sharp. You know what? That. This is terrible. I'm really bad at drawing. I'm sorry. Wait. What if I do like, there we go. That's a pretty good bullet. All right. Now in 3, 2, I'm also going to turn the animate step way down so it's slower. 1. All right, slow motion. The bullet kind of broke, so I'm adding a little bit more to it. And Impact! Oh! See, if that was a tank shell, look at how it spreads out the energy, and it made it all the way through. It made it all the way through. No way, but look at how it spreads out, and this is a lot how the force, the shockwave of force actually happens when you have something like a bullet hit something. You get that cone of damage. It's not just a line when a bullet hits something. There is this cone, this shockwave of force that comes out, and you can see the bits of the bullet that are left over afterwards. It shattered into smaller pieces, and this is super accurate. Like, again, this isn't what this game is designed to do, but because the physics are so good, you can do things that the game was never intended for. So all right, there we go. There's our bullet. I'm gonna flatten the end so it kind of looks like a tank shell. I'm using the word bullet, but this is more of a tank shell. It's much larger than a bullet. Thank you for understanding. And then let's go ahead and see what happens this time. All right, so remember, this is slow motion, and we are accelerating. We are accelerating. Now, this initial impact, you're gonna, wow, no, it went straight through that. Although it did cause the cone to form earlier. A little bit, and the added mass of the stone is definitely slowing down the path of destruction, although it still made it all the way through. Wow, even this little bit here made it all the way through. And now any second now we are going to see impact with this soft earth layer, and you can see it getting pushed out of the way. And it's impacting, it's still heating up on impact, but look how it's crushing the cell in its shell. And this time it's not just melting everything in its path. We're actually seeing kind of, it did heat up on the initial impact, but wow, I'm actually shocked. It is just continuing through. And I do wonder if this is, yeah, the magnet is still causing it to be accelerated this far away. That's a problem. Let's turn up the power so that it's squared. Yeah, I think it was linear. I think that was the problem. I think it was linear, the rate of acceleration. And now I think it's squared, which means, yeah, at this distance, it is not going to do anything. Okay, all right, but this is how we learn. This is how we learn. Still got some really cool results here, just how it crushed everything in its path. I mean, of course, if it's being accelerated the whole way through, then there's no chance of anything to survive. Imagine a bullet that never stopped. That would be, the government would be hiring you in a heartbeat to build their defense technology. Raytheon, they'll give you a lot of money if you invent that. Except if you can't stop the bullet, I guess it'll just keep going forever and eventually kill everyone. All right, all the way back here, it should actually accelerate things, but we're gonna go ahead and make up for the fact that we did that by turning the power up a lot. So now let's see what we get. No, we need it to go faster than that. We need more speed than that, come on. Man, it's very slow, and I felt like I raised the max velocity, so it shouldn't be that. Oh, I have to hit enter after. I have to hit enter after. Here we go. Here we go. Okay, this is gonna be intense. Oh, that's what we want to see. Okay, that was much better. It impacted and it slowed down because there wasn't a constant force being applied to it, and it really did just get. It got pretty far, actually. It did actually get pretty far. But there's a few things I want to test. Like, for example, in the real world, water is extremely effective at slowing down bullets as well. I wonder if we put like a water layer in here. But let's do one thing at a time. That was really cool. And that shows us that we can increase the speed. And we could actually also increase the CD heat multiplier again. It's not as much of an issue as I originally thought. All right, so let's go ahead and increase the speed even further. We're gonna quadruple. Oh, yeah, that is bullet speed. The only issue is that it's so fast that it rips the bullet apart. So let's try to do this. Build the bullet first and hit then. Oh no! Oh man, it is too much. It's too much force. All right, half of that. Oh my god. That's basically buckshot. Oh! Oh man, look at that. Look at the damage that did. Holy moly. Alright, let's go ahead and see how this does with a like normal sized bullet. Alright, we're gonna pause. I'm gonna actually do like a tiny little bullet here, and oh, look at that. Yeah, that was much better. So it made it about that far. But if I were to like rapid fire these, let's see how long it takes to break through rapid firing these little bullets. It's kind of hard to aim them. So they're definitely impacting. The closer I put them, the more powerful. If I put it right next to it, boom. Boom. If I keep hitting the same spot repeatedly, I wonder. Yeah, look at that. Look at the effect. It's really ripping into it. But I think we can increase the effect as well by increasing the maximum velocity. So let's double the maximum velocity of the simulation. It doesn't seem like it's actually getting that fast in the first place. So let's double the power of the magnet. Oh my god. Whoa. That makes it get much further. Okay, double the power of the magnet again. Now we're just getting to crazy town. Like, these bullets are going so far. All right, let's clean up a little bit. Let's clean up our mess. I still do want to answer that question about water as well. I'm wondering if the water will slow it down. So let's go ahead and make a water layer. Let's go ahead and just cut a hole in this. Don't worry about it breaking. I'm a professional at fixing things. Boom. Fixed. As I said, I'm a professional. Okay, I may have to fix this a little bit more. Okay, here we go. And then we're gonna fill it with water. Okay, I said water, not ice. Okay, let's go to scene, sky, turn, temp 0. Not, it's temp H that's being mean. I'll turn this up to like 20 degrees. There we go. All right, now we're gonna get water. So a liquid like water is very good at slowing down a bullet. Not as much as like metal, of course, because a literal sheet of metal is going to be very effective at slowing down a bullet. But you know, you see the things in Hollywood where people shoot into the water and the bullet slows down. I want to see how it simulates in this. I'm really curious what it's gonna look like. Of course, I can't really do proper slow motion, but we're gonna just try to keep our eye on it and see what happens. All right, ready? 3, 2, 1. Oh no! It went all the way through. The water did not slow it down really at all. Like it slowed down when it hit here, but the water it just flew through. The interesting thing is the shock wave you can see that the bullet leaves behind in the water. Keep an eye on the water for that shock wave this time. Look at that. See that? Yeah. And it's actually bouncing. The shockwave is bouncing off of the walls as well. So good. So good, the simulation. You ready? Look at the shockwave. Look at that. Whoosh. And when it hits the wall, it bounces back and reverberates. That is just awesome. And honestly, the entry of these bullets, I guess the water is slowing it down quite a bit. Because it's not making it through the stone over here at all, really. So I don't think it's doing as much as the stone is, but it's definitely having an effect. I was wrong originally. I wasn't thinking about it correctly. It's stopping them here, which means that it must have slowed down in the water, because if it didn't slow down in the water, it would have went further into the rock here. So let's just continue hitting it. I mean, at some point the water will drain and this entire experiment will end. But wow, this is a lot of fun. And you may wonder why they're sticking to the right, and that's because the magnet still has a tiny bit of force on them, but it's not nearly as much. And you can see as the water kind of gets moved out of the way. Sorry about that Valor notification sound. As the water gets moved out of the way, these are having an easier time. This one actually broke into that wall a little bit, and this water is starting to leak, which means that our protection is going away. There's no gravity though, so the water isn't being like pulled out or leaking. Well, not like in gravity it would. It's just kind of moving out of the way. It's getting concentrated in the cracks and stuff. All right, let's do some rapid fire machine gun here. Wow, it took so many shots. It took so many shots to actually break through this. Like, if you were inside of this pod, like, you'd probably be absolutely terrified for your life, but it's blocking a lot of these bullets. A lot of them. Dude, this game is now the ultimate gunfire simulator. Look at it go. Oh, I can just go like this. I just hold it down. Hold it down for the ultimate assault. Okay, whoa, wait. Last thing before we end this. Last thing before we end this. I'm going to do this again, but I'm going to absolutely... I'm going to do absolute overkill here. We're going to build a massive wall. Absolutely massive. And then we're just gonna rapid fire. We're gonna rapid fire hard. All right, ready? 3, 2, 1, rapid fire time. Look at how it cracks through the stone, but the stone is still doing pretty well considering. It's only getting through, the bullets are only getting about an inch. Getting about an inch in. And they're kind of stacking up and forming like their own defensive layer. Like there's this layer of metal building up. I wonder if I just like larger bullets. Yeah, that's a little bit more effective, moving it a little bit more slowly. But no, this is doing a really good job of defending. If I focus in one spot, I can break through. But with like a spread, it takes quite a bit. It takes quite a bit. All right, guys. I think that this is has been an absolutely exciting experience. I mean, we have built a proper railgun, but the question is, where can we go from here? Like, the sky's the limit. And actually, we're gonna do one last thing. We're gonna do one last thing because I want to see the railgun fire at a planet. I want to see the rail... Oh no, the game crashed. Well, I guess we'll have to do it next time then. Thank you all for watching. Leave a like and subscribe if you enjoyed, and I'll see you all next time. Peace out.